So you can start, sir.
Okay. Good evening, everyone. This is Dr. Abhijeet, and welcome to Oracle 21 Days Revision Series live class for university exams. And the topic that I will be discussing up today, it is biological oxidation. Now, in this, we are going to rapidly revise all the important questions in a very crisp, concise, and conceptual manner. All the volatile topics will be revised, all the previous year topics, the potent examination questions will be discussed over here. Apart from that, guys, it is beneficial for all the students who are going to appear for the university prof exams, as well as for the ones appearing for the next or the NEET PG or the INI CET or the FMG exam, right? So that is something you guys have to remember. Now, the questions that I will be covering, I will be covering the entire topic today. I will be covering all the steps, right, or related to the electron transport chain, the concept, how ATP is being synthesized, okay, the high energy phosphate, the cytochromes, the uncouplers, okay, and P and O ratio and respiratory control. Everything I will be, covering up today in a very, single screen today, right? Now, guys, why to choose Oracle, guys? You already know we have the recorded classes for flexible learning, guys. Once, guys, you're not able to learn, okay, I would say if you're not able to learn live, guys, you can always go on for these recorded versions which are available on the app, right? So yes, we have the live classes that are being scheduled daily from 6 p.m. to 10 p.m. And we have the practical sessions that are recorded, and you can go on for these practical videos later on for your practical exams. We have the express exam module in which we try to cover the entire topic under 20 hours, right? And we have the hard copy book set that is available at your doorstep. This is curated by the expert team covering all the important necessary information with relevance to the fun zones, riddles, MCQs, and everything. So we have already told you about the foundational classes for flexible learning, right? So you can always go on for this. We have the live classes that are scheduled daily. We have the express exam module, which covers the entire syllabus in under 20 hours. In this, basically, all the important aspects of biochemistry are discussed, right? All the previous year topics, the questions that have been frequently repeated in all the university exams. So all over India, right? So they are also being covered. We have one-to-one doubt clearing session. If any of the student faces any doubt in any particular subject, he can always book a prior appointment with the team and can know clear his or her doubt, right? So there is one-to-one approach also available. We have the hard copy book set. We have already told you just to reduce the burden of your heavy textbooks. We have curated this, and these are all curated in no reference, keeping in view the long answers, short answers, and essay types of questions, right? So yes, we have the question bank which covers the question from basic to advanced level. Now, when I say basic to advanced level, we have one-liners also, and we have clinical vignettes also nowadays, the hot favorite of the examiners, right? These also covered the previous year topics, the previous year questions of all national institution examinations like FMG, NEET, PG, okay? And guys, we have practical sessions, right, which are the videos where are recorded, and you can also prepare all for your practicals and the Viva voice, right? So our subscription plan, we have the foundation plan, guys, right? We have the advanced learning plan, we have the complete learning plan, and we have the ultimate MBBS plan. You can use my code Dr. Abhijeet 20 for additional discounts, right? Now let us just start with the electron transport chain. Let us start with the electron transport chain. Electron transport chain. Now, when I say electron transport chain, guys, let us first discuss some basics. Now, I hope you already remember when I say basics, guys, I'm going to discuss some terms over here. The very first term that you should know, what is oxidation? And the second one, what is reduction? What is oxidation and what is reduction? Now, when I say oxidation, guys, it is always loss of electron, right? Or I can simply say Oxidation means addition of oxygen. In very simple language, it is addition of oxygen. Reduction means removal of oxygen. Removal of oxygen. Now, other definition, guys, you should also remember that oxidation means removal of hydrogen. Removal of hydrogen or removal of electrons or removal of electrons, right? Reduction means again addition of hydrogen. It will be opposite of this. And reduction means addition of electrons. Addition of electrons, right? Or we can have one more definition, guys, over here. Oxidation also means increase in oxidation number. Increase in oxidation number. Increase in oxidation number. Now, guys, let us just take an example. You already know that we have iron, right? Let me take this example that this iron basically exists in two forms, Fe plus 2 and Fe plus 3. Now, Fe plus 2, it is called ferrous, okay? And Fe plus 3, it is called ferric. And in the intestine, in the stomach, basically this Fe plus 2 will change into Fe plus 3. So Fe plus 2 will change into Fe plus 3, right? So you can very well see that from plus 2, we have plus 3. Okay, from plus 2 we have plus 3, so there is increase in the oxidation number, right? We have plus 2 over here and we have plus 3, so we can say it is oxidized. The ferrous is oxidized to ferric, right? Even we have, okay, let me take one more example. We have iodine, right? This iodide, right? And it exists in two oxidation states, so we have -1 and 0. So we can also say that this is also an example of oxidation, right? This is also an example of oxidation. Now, let us just take an example over here, guys, that for example, there is some substrate which is changing into product, right? Some substrate which is changing into product. Now, when I say oxidation is happening over here, oxidation is happening over here, it means that there will be removal of hydrogen. There will be removal of hydrogen, right? There will be removal of hydrogen. Now, this hydrogen which is removed from the substrate to yield the product will be accepted by will be accepted by NAD plus, right? And will be accepted by FAD, right? It will be now what it will be do? This NAD plus will accept this hydrogen plus H2, and this FAD will also accept this H2. Now, what it will form, guys, what it will form, this NAD plus will form NADH plus H plus, and FAD will form FADH2, right? Now these are the ones, this NADH and FADH2 will enter into the electron transport chain to yield the ATP, to release the ATP, to release the ATP, right? Now, what is this NAD and NADH? Now, these are something that are called as redox couples. Let us now focus on some important definition also in the basics only. We have something called as redox couple. Now, redox couple, it is a compound. It is a compound that can exist in oxidized as well as reduced state. Okay. For example, NAD plus. Now you already know this NAD plus. Okay. This NAD plus, it is not having the hydrogen part. Okay. The hydrogen is already removed over here. So I can say it is oxidized, right? There is no hydrogen. There's no hydrogen over here. Okay. So NAD, and when I say NADH, it is having the hydrogen component, right? Hydrogen component. So NAD plus, it is oxidized, and NADH, it is reduced. Now, other thing, if we have FAD and FADH2, FAD, it is also oxidized. FADH2, it is reduced. It is reduced, right? So now we have understood what is the oxidation and what is reduction over here. We have noticed what is oxidation and what is reduction over here, right? Now, there is something called as redox potential. There is something called as redox potential. Now, redox potential, it is the ability to transfer electrons or gain electrons. It is the ability to transfer or gain electrons, right? Now, if there is more redox potential, if there is more redox potential, there will be more ability to gain electrons. There will be more ability to gain electrons, right? So if we have more redox potential, there will be more ability to gain electrons. Now, when we say electron transport chain, electron transport chain. Now, it is nothing but a series of redox couple arranged in ascending order of redox potential. A series of redox couple arranged in ascending order of redox potential, right? So let us just take an example. If there is something called as A, right, and there is something called as B. Now, whenever an electron jumps from low redox potential to high redox potential, it is an exergonic reaction. It will liberate free energy. So remember that when electron jump from low redox potential to high redox potential, it is an exergonic reaction. Okay, it means that it liberates free energy. Now, what is the concept of electron transport chain? Let us just discuss the concept of electron transport chain. Now, Now we want to generate ATP from reducing equivalents to get no that we get from various sources. Now you guys already have the macromolecules. We have the carbohydrates, we have the fats, and we have the proteins. Now all three of them, all the three macromolecules will be now forming the acetyl coenzyme, right? It will be now forming the acetyl coenzyme A, acetyl coenzyme A, right? Now this acetyl coenzyme A through various metabolic reactions, okay? Now where it will go in TCA cycle. It will go in TCA cycle, TCA cycle, tricarboxylic acid cycle, or also known as Krebs cycle. Krebs cycle, right? Now from there, what is generated, guys? You already know we are generating, yes, NADH2 and FADH2. NADH and FADH2, NADH and FADH2. Basically, one NADH basically gives how many ATPs? 2.5 ATP, and FADH2 gives 1.5 ATP. Now these two, to generate these ATPs, these both will now enter, guys. These both will now enter, yes, the electron transport chain. These will now enter the electron transport chain, where what will happen? Where phosphorylation will take place. Phosphorylation will take place, and what will happen, guys? This ADP, adenosine diphosphate, will be converting into ATP, right? Okay, and basically this um, NADH. So yes, over here, what will also happen, guys? They will be oxidized. This NAD plus and FAD plus will be no oxidized also. They will be oxidized. Removal of hydrogen will be there, right? They will be oxidized as well, and obviously it will be low, giving us energy, right? So yes, this electron transport chain, it is also known as oxidative phosphorylation. Oxidative phosphorylation. And remember, yes, it is oxidation plus phosphorylation. Oxidation plus phosphorylation, right? So now let us start the very first part. What is the location of electron transport chain? So we have just started with the know some basics. We have started with redox couple. What is redox potential? We have started with what is the definition of electron transport chain and the concept, right? Now let us first start. Where is the location of this electron transport chain? Location. Now location, it is the inner mitochondrial membrane. Very, very important. It is the inner mitochondrial membrane. Inner mitochondrial membrane. It is the inner mitochondrial membrane. Now remember, guys, this inner mitochondrial membrane contains something that is called as the series of complexes. We'll be coming to this. It contains series of complexes. Okay. Now, what are the components, guys? We have discussed the location. Now let us just try to discuss what are the components. Okay, and how the cycle is taking place. Let us just try to draw it in a very simple manner. We have the outer mitochondrial membrane and the inner mitochondrial membrane, right? So yes, inside we have the yeah. the intermitochondrial matrix or the space is there, right? So we have something called as complex 1. We have something called as the complex 1, right? Now this complex 1, it is NADHQ. Sorry, NADHQ. So basically it is also known as NADH dehydrogenase. It's also known as NADH dehydrogenase. Okay. So remember guys, this NADH is basically oxidized, right? And this Q, it is basically reduced, right? So basically this complex 1 is fixed guys. So we have this, yes, NADH basically changing into NAD plus. Now when I say NAD plus guys, now you can understand this is oxidized. Now this hydrogen or the extra electron guys will be jumping over here. We have this extra electron, right? So this extra electron will be no changing into the reduced form, this reduced electron, right? So basically, what is the carrier, guys? Over here, we are using this carrier to now carry this electron forward. Okay, this carrier, guys, is very, very important over here. This is nothing but coenzyme Q or ubiquinone. Remember, it is ubiquinone or Q10 isoprene units. Isoprene units. Now, this ubiquinone, it is the mobile carrier or the mobile electron carrier. It is carrying this electron inside, right? It is the mobile electron carrier, right? Now, what are the components of complex one? This is again very, very important. What are the components? So we have FMN, that is flavin mononucleotide, right? And we also have iron sulfur complex. Iron sulfur complex. We also have FMN and iron sulfur complex, right? So that is regarding this. Now, coming on to complex 2, we have actually 5 complex 1, 2, 3, 4, 5. So let us now discuss complex 2. Complex 2. Yeah. So basically what is happening over here, the succinate, let us assume this is the complex 2. Now what is happening guys, succinate is changing into fumarate. Succinate changing into fumarate, and the electron that is extra over here, okay, so this fumarate, it is basically oxidized, okay. Now this electron is carried by the Q component, right? So basically we have yes, the complex 2, it is succinate, Q oxidative, right? Or it is also called as succinate, Q reductase, right? Now what are the components guys that you have to remember? One is FAD, and the second one, it is the iron sulfur complex. Right? Now the third one, the complex 3, Okay, we again have this, yes, the membranes, and yes, the complex 3. Now this Q, guys, this Q over here, it will be, no, it's carrying an extra electron. This Q will be oxidized, and this electron will go into now this complex 3. Okay, and again there will be no cytochrome C, okay, which will be now reduced, right, because it is carrying that electron. So this complex 3, it is also known as Q cytochrome C reductase. It is also known as cytochrome BC1 complex. Okay, now what are the components, guys, of this? What are the components that you have to remember? It is having cytochrome B. Okay, we have cytochrome C1, right? We have risque ferrous sulfur complex. Ferrous sulfur complex. Now coming on to complex number 4. Coming on to complex number 4. Now we have the two membranes over here, right? So we have, yes, this complex 4. Now this cytochrome C, which was carrying that electron, right, that hydrogen, okay, now it will be oxidized. And this electron will pass into this complex 4, okay, and that will be accepted by the oxygen, and it will form water. It will form water. Now this complex 4, it is also called as cytochrome C oxidase. Okay, it's an irreversible one. It's an irreversible. It is the final acceptor of oxygen. Final electron acceptor, it is oxygen, right? And the components, guys, you already know. Yes, we have heme component, that is AA3. It's also called as cytochrome AA3. Okay, it also contains copper. So we have copper A, copper B, right? So these are the components of complex 4. Now coming on to fifth complex, complex 5. We have complex 5, or the fifth complex. It is ATP synthase, right? Now it contains two subcomplex. We have F0 and F1. F0, it is F0 subcomplex, and we have F1 subcomplex. We have F0 subcomplex and we have F1 subcomplex, right? Now, so let us assume that this F0 part is in the matrix and we have this F1 part, right? So F0 is basically made up of C disc proteins. Okay, it is made up of C disc proteins. Okay, 10 C disc proteins are there, right? It is hydrophobic. Okay, it is hydrophobic. It spans the inner mitochondrial membrane. Okay, it spans the inner mitochondrial membrane, and it is a proton channel. It is a proton channel, right? Now F1, it is basically made up of three components, guys. Made up of three components, and it is nothing but there are like three components which it is made up of. Okay. So yeah, let us just try to read that first. It is the 9 subunits, and it is 3 alpha, 3 beta, gamma, delta, and epsilon, right? Now these 3 beta are the ones, it is the ATP synthesizing subunits. It is the ATP synthesizing subunits, right? Gamma, it is bent axial. Okay, gamma, it is bent axial, right? This one, this is the gamma, right? And we have the 3 beta components. Okay, now bent axial, it is basically the rotating unit. The rotating unit. Okay, now this gamma basically connects F0 to F1, connects F0 to F1, right? So this is the gamma component, and we have this F1 component also over here. You can just, it spans the inner mitochondrial membrane completely. Okay, and yes, it is made up of 10 C disc proteins, right? It is hydrophobic and it is like completely present. Now, guys, we have something called as the oxidative phosphorylation. Okay, we have the oxidative phosphorylation. Hmm. Now, these are the various components of the electron transport chain. Now, the third one that we have to remember, it is the oxidative phosphorylation. Now, guys, remember the complex 1 and complex 2. We have NADH dehydrogenase. Okay, and we have succinate dehydrogenase. Okay, so basically, yes, NADH dehydrogenase, you already know we have this NADH plus H plus, right? It's changing into NAD plus, right? And we have, yes, FADH2 getting oxidized to know this FAD plus. Now, both of them, yeah, basically the electrons are carried by coenzyme Q or ubiquinone. They will now enter complex 3, that is cytochrome reductase, right? That is nothing but the cytochrome C, the cytochrome C. Now this will enter complex 4, that is cytochrome oxidase, where I told you the final acceptor, it is the oxygen. And yes, so it is the oxidation which is taking place. And after that, we have the cytochrome C, I mean, the complex 5. Okay, it is the F0 F1 particle. Okay, where what is happening, the ADP combines with the inorganic phosphate to form ATP, and this is phosphorylation. Phosphorylation. So we have oxidation in complex 4 and phosphorylation in complex 5, combinedly known as oxidative phosphorylation. Combinedly known as oxidative phosphorylation, right? So this is something you have to remember, right? Now, we have to also discuss today the inhibitors of the respiratory chain. The inhibitors of respiratory chain. Now, guys, here the first component that you have to remember, we have inhibitors of electron transport. Inhibitors of electron transport. We have complex 1. Inhibitor, it is rotenone. Rotenone. You can just remember with the help of this one, rotenone. Okay. So yes, We have MO-barbital, MO-barbital, okay? Or we also have pyricidine A, pyricidine A. MO-barbital, it is nothing but the phenobarbital only. Then we have complex 2. Okay, the inhibitors, guys, that you have to remember, it is malonate, yes, carboxyl, right? So basically what is happening over here in complex 2? FADH2, it is basically changing into this Q, enzyme Q, so it is inhibited. Complex 1, it is NADH, this Q, it is basically inhibited over here, right? We also have trienoyl, trifluoroacetate, okay, trienoyl or enoyl trifluoroacetate, TTFA. Then we have complex third or complex 4. Now, complex third, basically, it is very, very important. It is the British anti-leucite, that is BAL, and antimycin A. Antimycin A. Component 4, it is carbon monoxide. Okay. We have cyanide. We have H2S, sodium sulfide, right? Hydrogen sulfide. We have sodium sulfide also. We have sodium azide. And these are all gases. All gases. Now we have the inhibitors of oxidative phosphorylation. Inhibitors of oxidative phosphorylation. F naught, it is oligomycin. We have venturecidine. F1, we have orovertin. Orovertin, right? So yes, uncouplers. Now when I say uncouplers, guys, one more question of today, that is the uncouplers. Uncouplers, oxidation and phosphorylation. Okay, we have chemical and physiological. We have chemical and physiological. Chemical uncouplers, basically we have 2,4-dinitrophenol. Okay, we have dinitrocresol. Okay, we also have aspirin. Okay, we have FCCP, that is fluorocarbonyl cyanide phenylhydrazine. Physiological uncouplers, basically they include thermogenin. Okay, thermogenin, it is also known as uncoupler protein 1, UCP1. Okay, it is present in brown adipose tissue. Okay, it is present in brown adipose tissue, right? We have the second one in this category as thyroxine. We have long chain fatty acids, right? We have unconjugated bilirubin, as well, unconjugated bilirubin as well, right? So that was regarding the inhibitors of the respiratory chain, right? The inhibitors of the respiratory chain. Okay. So yes. No. Hmm. So that was regarding today's lesson. We have already covered all the important concepts for today's part, right? We have covered, yes, the electron transport chain, the P6, right? We have covered the redox couple, the redox potential, the electron transport chain definition, concept, location, components, the various complexes, 2, 3, 4, 5. We have discussed how it no, goes on through, right? The inhibitors, right? Yes, if we just want, we can just discuss one more small topic over here, that is oxidative phosphorylation. Already have discussed it. I just wanted to make a diagram and explain you oxidative phosphorylation. Now, let us just try to see over here what is happening. Now, we have this let us we have this inner mitochondrial membrane. Now, let us suppose that this is the inner mitochondrial membrane. Outside, we have the intermembranous space, and more on outside, we have this outer mitochondrial membrane, right? So we have this complex one, right? So yes, we have this electron which is no carried by this Q component, right? To this complex 2, I mean the 3 complex, right? Then we have the cytochrome C, then we have the 4th complex, and ultimately we have this, yes, the F0 and F1 particles are there. The 3 beta particles are there. Now you already know from NADH, it is NAD plus. Basically, this electron which is now coming from this NADH. Okay, so the electron is jumping. Okay, we are generating 4 hydrogen from here, 4 hydrogen from here, and 2 hydrogen from here. So total we have 10 electrons or 10 hydrogen, 10 H plus, right? So oxidation, remember, right? The first and the third part, right? So remember, we have electron jumping and there is releasing of energy, and this pump hydrogen to the intermembranous space. So we have like 10 hydrogen plus, right? So there is pumping of proton. So it creates a potential difference. Okay, hydrogen moves to mitochondrial matrix through F0 subcomplex, and then there is rotation of gamma subunit. Now this is something called as phosphorylation. Phosphorylation, right? Phosphorylation. Now what happens? There is conformational change. Conformational change in the beta subunit. Okay, and each subunit covers basically ADP to ATP. From one NADH, guys, remember, from one NADH, basically 10 electrons are pumped to inner mitochondrial membrane to 3 beta subunits. So it is approximately 2.5 roughly, right? So this theory, it is also known as chemoosmotic theory, put forward by Peter Michel, right? So that is the oxidative phosphorylation that you guys have to remember more, right? So that was regarding today's topic. I hope you guys understood this, right? So yes, thank you for your patience and listening me out.